A pretty easy section, 5.1. We're going to talk about operations with like polynomials, right? The polynomial, we talked about that in like the very first, right here. We talked about it in like early on the year, I think second quarter, right? Polynomials like anything in the form ax squared plus bx plus c and all of that stuff. But first we need to learn how to do operations with monomials. A monomial is an expression that looks like this: a x to the n, a x to the m, y to the n. It's just one term, right? One term. So that's called a monomial. It's just one term, okay? So now, what are we doing here? We're going to learn how to, the product rule with monomial. How do you multiply them, right? If I have, for example, x squared times x to the 5, what does that give me? That's the kind of stuff that we are talking about in the very first subsection here, or subheader, or whatever, right? If I have, for example, x to the power of a, and I want to multiply that times x to the power of b, what I'm actually doing is this. Because the base is the same, right? All you're going to do is just add the exponent. Does that make sense? Right? We have the same base. The base is x and x, right? This is x to the a times x to the b. If because the base is the same, the base is the x, all you do is just make it one single expression and then add the exponent. Example, 3 to the 4 times 3 to the 6 is equal to 3 to the 4 plus 6, which is 3 to the 10. Right? You guys did that before?
Yeah.
All right. So it's like...
I desperately needed this reminder, though.
All right, so that's the product rule for monomial, right? So x to the 5 times x to the 6 is x to the 11. As long as the base is the same, you add the exponent, right? Now, this is just a quick, we're just going over the rules real quick, and then we're going to get into the meat of the thing, right? Now, when you divide them, now division is what really throws a lot of people off. People get confused when it comes to division, right? For example, if I have x to the a and I'm dividing by x to the b, what I'm going to do is it becomes, again, the base is the same, is x to the a minus b, right? Example, 5 raised to the power of 7 over 5 to the third is equal to 5 to the power of 7 minus 3. Does that make sense? Which is 5 to the 4.
No.
Right? 5 to the 4, then you can find what 5 to the 4 is.
Because you move 3 exponents.
So when base is the same,
5 and exponent of 0, which makes it 1 over 1. So
that's right. Right?
Alright.
So x to the a over x to the b is x to the a minus b. If this is the one that you move. You move this up here and you subtract it. Because every time you switch from the bottom up or top to down, you change the sign of the exponent, right? So x to the a over x to the b is x to the a minus b. So 5 to the 7 over 5 to the 3 is 5 to the 7 minus 2, which is 5 to the 4. But you have to make sure the base is the same. If the base is not the same, this is the base, you cannot do that, right? For example, if I have 6 to the 7 over 5 to the 3, it's not going to be 6 to the 7 minus 3. You can't do that because the base is not the same. You have to make sure the base is the same, right? Are we understanding this? All right. It seems like everybody's on the same page, so we're good, right? And now we're also going to deal with negative exponent. So how do I deal with a negative exponent? So if I have x to the negative n, right? There's no I here, right? X to the negative n is equal to 1 over x to the n. This is, again, one of those formulas that you need to remember, right? It's not a formula, it's just a rule, right? So example, if I have 7 to the power of negative 2, it becomes 1 over 7 squared, right? X to the negative n is 1 over x to the n. Example, 7 to the negative 2 is equal to 1 over 7 squared, which is basically 1 over 49, right? So what if I have 8 to the negative 4? Shay, what would that give me?
What?
8 to the negative 4. If I want to get rid of negative exponent, what would that give me? According to this rule.
Oh, I don't know. Can you pick on something else?
1 to the 8 over 4.
1 over 8 to the 4, right? This is 1 over 8 to the 4. Yeah.
On the dividing one,
Mm-hmm.
to finish the equation, will we
do the 5 to the power 4 to finish it? Or
You
we
can.
do that at the end?
Well, it depends on what the question is. If the instruction is asking you to do it, then yes. But if not, then you can just leave it here.
You can take points off if we do it anyways?
I don't know. It's based on the question that is being asked. If I ask you to go further, then you can. Now here, I know that 7 squared is 49, so I'm not going to leave it as 1 over 7 squared. It's 1 over 49, obviously, right? Okay. Tell me, what is 6 to the power of negative 7? If you want to get rid of negative exponent, what would I give you?
1 over 6 to 7?
Are you telling me?
Oh, you said take it?
Yeah.
I'm sorry, I didn't hear you.
1 over 6 to the 7.
All right. That's all right. She saved you. Did you know it?
I'm sorry, I didn't hear you.
All right, good. All right. Now, the next one is called the power of a power, right? Power of a power. So, x to the a raised to the power of b equals to x to the ab.
What?
Right? X to the a, the whole thing raised to the power of b is equal to same base to the power of ab. All these are just rules, right? Just rules that we're going over. So example, 3 to the 7 raised to the power of 2 is equal to 3 to the 14, right? Some people confuse this and that sometimes. A lot of people have done that. I've seen this like years before, right? Now look, there's a distinction between this here and then this here, right? A lot of people who see this, x to the a, x to the b, and they go, oh, this is x to the a times b. No. When the base is same and you multiply, then what do you do to the exponent? Plus, right? You add it. And then here, you multiply. So you have to remember that. These two things are different, right? These two things are different. A lot of people have done, I'm telling you, like, I've seen it so many, last year I saw it, right? So I've seen it a lot of times. So example, 3 to the 7 raised to the 2 is 3 to the 7 times 2, which is 3 raised to the power of 14. Is anybody lost? In this
You're just
section?
overloading my
Nobody's
brain right
lost.
now.
It's not overloaded.
It's just too many to
Just
remember.
going a little fast.
It's just so many to remember.
Because do you know why I'm going fast? Because it's just rules.
Yeah.
It's in your book, right? Oh, sure. Yeah, thanks for reminding me. It will come
Never
soon.
ask about homework. I will
Now, the next one is called the power of a product,
It's legal.
right?
Power of a power.
X,
Money.
xy raised to the power of m is equal to x to the n times x to the n. Example, if I have xy raised to the 7, each expression here is going to be raised to the power of 7. It will be x to the 7 times y to the 7. Okay? So this is called the power of a product. Okay? That's called the power of a product. And then we also have the power of a quotient, right? Quotient. So if I have xy to the a, raised to the a, each one of the expression is going to be raised to the power of a. So xy, the whole thing raised to the power of a is equal to x to the a over y to the a.
Do we leave it at that or do we solve it further?
Well, you can't do anything here,
Okay.
obviously, right? Now we have 2 over 5 raised to the power of 5. That is 2 to the 5th over 5 to the 5th, right? Because again, each one of them is going to be raised to the power of 5, right? Now, the next one here, do you see what I did is I switched the exponent to a negative, right? So when the exponent is switched to a negative, all you do is flip the expression that's inside and then change the exponent to a positive integer, right? Or real number, whatever the thing is. So for example, x over y to the power of negative a is going to be y over x to the power of a. And I'll give you an example here. 5, 3, 7, 3 over 7 to the negative 6. It becomes 7, 3 to the 6, and then each one will be raised to the power of 6, so 7 to the 6.
So do you just
Three to
flip
6.
your x and y?
You just flip your x and y and change it into a positive exponent. Right? These are just the basic rules that are gonna dictate how we're gonna deal with this section. It's almost like this is your baby stage. First you crawl, then you walk. I'm in the crawling stage right now. We're crawling first.
So it's about to get really hard.
No.
No, Shay, it's you crawl, walk, and cry.
Right? Now, 0 power. I love this one, right? Any number raised to the power of 0 is always going to give you what? 1. Right? No matter what. 10,000 to the 0 is 1. Negative 5,000 to the 0 It's 1.
One.
1, yeah.
Uno.
Not 1 as Y-U-A-N, but 1 as O-N-E. Alright,
Y-U-E-N?
Y-U-A-N.
Yawn.
One.
That's
1.
Yawn.
It's one.
One.
No, spell wrong with the Y.
Alright, can I erase this here? May I erase it?
No.
Jeez, Uno.
Why you say no?
Where's the-
No.
You said no, why?
No, I said yes.
Oh, okay.
It's like one.
I would like to point out that zero is the power of zero
I think
is
it's
over
like
numbers.
Excuse me?
or something like
Huh?
Zero is the power of zero is over.
It doesn't exist.
It's all real numbers.
Yeah, it's not, it doesn't
Zero
exist.
divided by zero.
Yeah.
No, don't worry. In like 2 weeks, we're gonna learn how it's actually the letter K.
Bad. Alright, now we're gonna learn how to do some quick simplification here. Simplifying an expression. Right? So let me give you an example. So now we're gonna apply the rule that we just learned. If I have 2a, right, raised to the power of negative 2 times 3a, right,
You just substitute.
b, and then b squared, and then
It's got
C.
complicated fast.
to the negative 2, right? And they want us to simplify this expression, right? So we need to simplify this. So I'm looking at it, I'm like, all right, I can simplify this, right? So what I want to do, I want to rearrange everything. So I'm going to put almost like, it's almost like putting like terms together, right? So I have numbers and I also have variables, right? So what I'm going to do is this. I'm going to do 2, right, times what? 3, right? 2 times 3, correct?
Wait, so can you take them out of there?
You can take them out of parentheses,
Okay.
right?
So not like a whole bunch.
Yeah.
Okay.
And then now look, I have a to the negative 2 times what? A to the 3. You see what I'm doing here, right? And I have b squared times c to the negative 2. So I'm going to rearrange it so that way it looks easier to deal with. Why's your head down, Mary?
Does my head hurt?
All right, keep it up. If you lift your head up like they won't hurt, trust me. I'm serious. Right.
6 or
So now we're
Actually,
going
about
to
the life.
no, like fix your eyes, gaze upon the board, and you'll be good. 2 times 3 is equal to what?
6.
6. I hope you knew that. Now here I have the same base, right? A to the negative
A to the
2.
first.
So what is that going to give me?
A.
A to the 1 or A to the first, right? Because it's negative 2 plus 3, which is equal to 1. So this is A, right? Now, b squared is by itself, so I'm going to leave it alone. Now, here's the thing. Again, this is one of those fundamental rules that we're going to do in this chapter. We can never keep a negative exponent. If you ever have a negative exponent and you turn it in like that, I'm going to deduct some point, right? So what do I do with this? It's a negative, yeah?
1 over c squared.
1 over c squared, so that becomes 1 over c squared, right? I don't leave it like this. Now, I can simplify that. C is going to be in the bottom, so it's going to be 6a and b squared, and this is your final answer, right? Does that make sense? Because we are multiplying the top by 1,
Oh.
right? So I give us 6ab squared, and then we're going to change this into a fraction because we learned that earlier. This is called the negative exponent rule, right? All right.
It's supposed to be foiled.
No, we can not go for this, right? So now another one. Now let's say I have. Now stop me if there's something that you don't understand, so I can go over it again, right? Because I do not want to leave any stones unturned.
I got questions on the homework from yesterday.
Oh no, I'm not doing that just yet.
From 2 weeks ago. Yeah, you said it was gonna be like 2 homework assignments a week.
Was it?
That's what you said.
That's what I said.
Did you really?
Yeah.
If there's one thing you can learn about humans is that they change. They're
That they lie?
fickle. I'm like, from Galatia, right? I'm fickle, so I can change, right? I'm not God, right? So,
So you do lie.
I don't lie.
Yeah,
I
you
say
did.
things can change.
No,
Lying is,
you said it's going to be. No, it
I
might
said,
be.
things can change. I can change my mind. That's what makes me
We all
unique.
can. Mine,
I can change my mind if I want.
I changed my mind on being.
I'm allowed to, right? Ah, hold on. So now we're doing this here, right? Now watch. So if you look, right? Wait a minute. We have that, right? So we're gonna have to simplify this. We need to simplify this, right? So I have x. So here's what I'm gonna do here. X squared over x is 7, right? So how do I simplify that into one single variable with one exponent? What is that gonna give me? Subtract, right? We're gonna subtract 2 minus 7,
Well, 7 over.
which is what? -5. So you should be x to the -5 here.
Mr. Swami,
That-
does it have to be x with x and y and y?
Excuse me?
Do you have to do like x and y?
Yeah,
and y?
you gotta do.
You can't go x and y.
No,
X and y.
no, because they don't have the same base. They have to have the same base, right? So y I got -5 here. I did what? 2, right? Minus 7. That's what we did in the last rule that we talked about. This is called the negative exponent, right? The quotient rule, right? You're going to do 2 minus 7 is -5. And then here, you're going to do what? 4 minus what? 3, right? So this is 4 minus 3. So that is y to the power of 1. And we have nothing under here, right? But now remember, we cannot have a negative exponent. So what is that going to give me then?
It's gonna give 1 over x to the 5th.
There you go. Thank you very much. Y times 1 over x to the 5th. And now I can just multiply y and 1. So that gives me what? Y over what? X to the 5th. Right? And like I said, my favorite saying, this is like a walk in the park. A walk in the park.
This one might actually. Yeah, this one
Yeah, this one actually would be good.
Yeah, I told you
This is
all.
actually a walk.
I told you.
time.
I told you all it was going to be fun.
Yeah,
Right?
Fun. It's about fun, but
Fun and understanding.
That was fun. It's fun,
Fun
isn't
is
it?
break.
All right. Next. Let's say we have this here, right?
Next.
Now -2a. It's gonna get interesting now. 4, right? Over b to the 2, and the whole thing raised to the power of 3, right? So this is called the power of a power, right? So I'm gonna raise each one of those entries of numbers and variables to the power of 3, right? So the first one's gonna give you -2 to the power of what? 3. And then a is gonna be raised to the power of what? Remember?
7.
No, not 7. Ah, you see? 12, but you do what? 4 times 3, right? This is where you have to be extremely careful. And then b is going to be raised to the power of what? 6. Because 2 times 3, so b to the 6. Is anybody confused here?
wait, can you just say it again?
So we're going to start with each one of those numbers, right? And the variables. So -2 is raised to the power of 3. Because this is 2 to the 1, right?
Okay.
And then a, because this is 4, you do 4 times 3, that gives you 8 to the 12. And then b is squared, and it's also raised to the power of 3, so
Oh,
I
I see
b6.
now. Yeah.
Right?
okay.
And then
You just
now,
have to add the 3 to everybody.
yeah,
Or-
every single one of them, multiply it, right?
Yeah, multiply.
And now -2 to the 3 is what?
12.
No, -2 to the power of 3 is -8, right? So this is -8, 12,
Oh, the power.
b6, right? And then that's it.
I know, I just.
We stop here, all right? There's nothing else to do here. We stop in this. This is the final, all right?
Isn't B6
Last one,
like
and then we get more.
No, we're not finished.
Isn't B6 like
We are not finished. All right, now I want you all to think. Your head
I
hurt?
think it's like a mental.
Oh.
Just tell me, where did the,
Wait, Tammy has a question.
Yes,
never mind.
Go ahead.
yes, sir.
Yeah.
What you need?
B6.
Oh, okay. All right, now watch here.
B6 is who died.
So let me ask you a question. How would you solve this here? You have a over 4 to -3.
Flip it.
Flip it, thank you, and then what do we get?
4 over A
To the
cubed.
3rd.
That's it. Very good. Right?
We're done.
Extra points.
So 4 cubed is what? 64 over what?
A.
A to the 3rd. Thank you very much. So you're getting it.
Wait.
What is it like?
Huh?
What's it like?
What? To
Walk in the park.
yeah, it's like a walk in the park. Walk in the park. All right. So the next thing we're gonna learn.
Next.
Oh yeah, we got a couple more things here. Yeah. Come on.
Sorry, can I go back?
Go, do it faster.
this guy.
We had you good try to cover for you.
This guy.
Oh,
Bro, I it took 6 years to
Mommy, cry about it.
Yeah, go ahead.
well, you can't act casual if you don't get the sound stopped.
Free pencil. Oh, I didn't know that.
All right.
Is it fine to finish?
Wolverine, please. Please don't tell me Wolverine. I know you're 200. I'm 100.
Jack, press the button. Jack,
Press the button.
press the button.
I'm not gonna press the button.
No, press the button.
I will never press the button.
The button.
All right. So now we're going to talk about the degree of a polynomial, right? How do we find the degree of a polynomial? So that's what we're going to discuss in.
Tomorrow?
No, right now.
For our heads.
Can we at
Is
least
that
work on our last
the
homework?
big, what's
We
the
can
second
not.
word after big? The big best degree or?
So let's say we have ax squared, right? Plus bx plus c, right? And I want to find the degree of this polynomial. So basically the degree of the polynomial is by definition the degree of the monomial with the highest degree, right? How many monomials do I have here? 3, right? I have 3 monomials. So I have this guy, I have this guy, and I have this guy, right? So if I want to find the degree of this entire polynomial, it's going to be the degree of the highest, of the monomial with the highest degree, right? So the degree is this here. This is square, this is 1, and this is 0. So what's the highest degree here? 2 is the highest degree, right? Because I'm looking at the exponent. The exponent is your degree. So therefore, I'm going to say the degree of this polynomial is what? Is 2.
Is that easy?
That easy. This is why, you know, like, I don't know why everyone complains, because it's that easy. Now I'm going to give you some examples and we're going to try to figure it out, right? So let's start with the easy ones. So let's say we have x to the 7 plus 3x cubed minus 1.
X is 7.
So what's the degree of this polynomial? 7. Because what's the highest monomial here? The degree, the monomial with the highest degree. 7. Does everyone understand that?
Yes.
Right? Excuse me? No? Okay. So this is called a polynomial, right? Because you have poly means many, right? Plural, right? So this polynomial has how many monomials? 3, right? 1, 2, and 3, correct? So now to find the degree of this polynomial, what you do is this. You find the monomial with the highest degree. And because he has the highest degree, that becomes by default the degree of the entire polynomial, right? So the degree is the exponent here, right? So if you look, we have ax squared plus bx plus c. So if I look at all these 3 monomials, which one has the highest exponent? A. So therefore the degree of this polynomial will be 2, right? Now here we have x7 plus 3x cubed minus 1. So what will be the degree of this polynomial here? 7, because the monomial with the highest degree is 7, right? Now, the funny thing is this, with this section there are some differences. We have some what was I gonna say?
Do we have homework today?
Excuse me?
Do we have
No, we
homework
only have
today?
15 more minutes.
Yeah.
Yes.
No, 15.
Alright, so what if I have
Did you charge for late homework?
$20.
Alright, here, right? Who's gonna freak out?
Nobody. Oh, stop being the Sprite.
I'm not burping today because I'm
Yes, you will.
Can I just
No, it's not.
say no?
Now here's the thing, right?
5.
No, it's not 5 either. Gotcha. So what we do here is this, right? Here's what we do. We still have a monomial here, right? Because it's one expression.
Oh, we're on the bottom one.
So we're gonna add, even though the base is not the same, we're still gonna add this. 4 plus 3 is what?
7.
7. Therefore, the degree of this polynomial is what?
Oh, because it's
7.
1 unit, so
Yeah.
the overall power.
So here, we
What
know
about the 5?
5 is less than 7,
1 unit.
What do we do?
right?
Because you divide into
So therefore,
Polynomial.
Yeah, but
4 plus 3
X to the 3
is 7,
X
right?
to
This
4.
is 5, and this is 3. The highest degree is 7, so therefore, the degree of this polynomial is 7,
Oh, so
all right? Now, what if I have this here?
Because it's 1 unit, so everything in there is counted.
They get you.
Yeah.
So what if I have this here? So, what do you say?
Right.
Is that, first of all, we have to look at it, right? Well, here's the problem.
Why'd you give us this?
Huh?
Wait, where'd you get the square root from?
Square root of x, right? Any number square root is that number raised to the power of what? If I have square root of x is the 1/2, right?
1/2.
Anytime you have square root of x,
Hold on, where'd you get the square root from?
square root of x is the equivalent of x to the 1/2, right? Now, the problem is this, x to the 1/2, because this is radical, this is not a polynomial. This cannot be called not a polynomial because we have a radical, right? Anytime you see a square root involved in the term, in the expression, this is not a polynomial. It disqualifies it as a polynomial. So this is not a polynomial. Does that make sense? Right? Because we have that, right? Because there's a radical here, it disqualifies this expression, and this expression is not a polynomial. We don't need to find the degree. There's no such thing. Does that make sense? All right. Now, what if I have this here? X to the negative 3 plus 2x to the negative 2 minus 1. Right? What do you see here?
Minus 1.
It's gonna be the 2x minus 2.
Well, technically,
Wasn't it?
it can't be either because guess what we have? If I change this becomes what? 1 over x cubed plus what? 2 over x squared minus 1. This again is not a polynomial because this is a rational expression.
Wait.
Ah.
Right? Because the
2 over?
2 over x squared, right?
Oh, okay.
So because this is like a negative exponent, again it disqualifies it as a polynomial. It cannot be a polynomial, so there's no degree to this. Okay? Because those numbers have to be positive integers. Right? If they're not positive integers, we do not have a polynomial. So therefore, this is not a polynomial. So therefore, you can't say that, so it disqualifies it. Does that make sense?
What do you use polynomials for?
To graph functions.
In real life.
Graph functions and then determine what the function is going to look like, and that's going to determine a whole lot of things. We just went on to me and Nate.
It's million